If I explain this just right, you'll probably think it's the easiest thing of the chapter. You'll wish this was on the quiz. One little thing. Yeah, one little thing I got to explain at the end, but pretty straightforward. Inverse relations and inverse functions. Long term, these aren't simple or easy, but they are for us in this course. What we have to do with them is pretty straightforward. When we use the word inverse in math class, when we're talking about relations or functions, and we'll mostly talk about functions. But the same thing I'm saying applies to relations as well. So if it's not a function, the same thinking applies. Anyways, we are referring to what it takes to reverse or undo what has been done. Some simple ones. The inverse of adding. What undoes adding? Subtracting. Okay, so if you're waiting for a trick question on this first page, you're just not going to get it. This is inverses. If you understand this first bunch of stuff, you understand what an inverse is. We got one little hoop we got to jump through later. Next, inverse of subtracting. Well, if the inverse of adding is subtracting, the inverse of subtracting is adding. So far, so good. The inverse, welcome. The inverse of multiplying. How about multiplying? What's its inverse? Dividing, okay? And actually, from a certain point of view, you might be like, oh, wait a minute. Now I'm starting to think through school a little bit and starting to understand what the process here was. In kindergarten, grade 1, you learn adding. The next thing you learn is the inverse, subtracting. Then in grade 2, 3, they teach you multiplying. As soon as you've learned that, they teach you dividing. You're always doing inverses. So we've been doing inverses the whole time. So why are we doing it today? Well, you'll see. The algebra of it needs a little bit of attention. There you go, sir. More examples. Slightly tougher. Stuff that didn't come till 7, 8, 9. The inverse of squaring. If you had x squared, how did you inverse that? How did you undo it? Square rooting. Now, I just want to mention something that will come up later, is that probably we should do plus or minus square root. You're supposed to have sort of seen that in grade 10. I'll just mention that now. I'll do more on it later. But I'll just write square root here, because I hope we know what we're talking about. Squaring, square rooting. Okay, I'll do the details in a minute. The inverse of square rooting, if we had to do that, which comes up less often, is squaring. There were others, by the way. You did sine and sine inverse, but let's not fall down that rabbit hole just yet. I'm going to do a whole chapter on trigonometry later, so we don't have to get, it's out there. Sine, sine inverse, yes, it's out there, but we'll just leave it on the shelf for now. We don't need it quite yet. Any questions so far? Hopefully that's like, hey, great stuff on a Friday. Thank you very much. This is just what I needed to build my confidence up going into the weekend here. On to the algebra. To write for a function f at x, this is new to us this year, writing f at x. Maybe it's new, maybe a little bit in grade 10. If we want to write the inverse function, we use this symbol, f with a little -1 up there. It's not an exponent, although it looks like an exponent. It's sort of an unfortunate math symbol because it doesn't exactly mean what you think it might mean. You go, oh, is that an exponent of -1? Is it 1 over? No, it's none of those things. It just means inverse. It might have been a better choice to write f with a little I for inverse up there. That might have been a better choice. But the I looks like it looks like another letter. So this is what mathematicians came up with. I don't know if it was the wisest choice ever, but this is what we're stuck with. This means inverse. When you see f with a little -1, that just means inverse. You don't have to think, oh, what does the negative mean? You don't have to think, what does the 1 mean? Don't think about any of that stuff. Don't even put a thought into it. It just means inverse. Same as it did with trig, right? Sine with the little -1 up there meant sine inverse. It's just a shorthand in math, okay? So from here on in, you might want to get out your highlighter or your red pen or something like that and just give that a little highlight. I don't know that that's that difficult, but you don't want to end up on test day, this not on the quiz, yes? You don't want to end up on test day and it says f with a little -1 there and you're like, I don't know what that even means. So that's a little bit new that we need that, okay? Okay, so the exact same examples again, but algebraically. If f at x is x plus 3, it's the function that takes x and adds 3. What will the inverse function do if the original function minus 3. Here's how you write it. So here's the only quirky part in the whole lesson, I think, is you'd write it like this. The inverse of that function is f with a little negative 1, x. That's how we write f inverse. F inverse of x would be x minus 3. And if that looks weird, it's only because it's new. It's not because it's complicated. All that's saying is the same thing I said in the previous page. The inverse of adding is subtracting. If I want to do an inverse function of adding 3, you subtract 3. Let me just jump ahead of thinking just a little bit. If you took the number 10 and subbed it into f at x, you'd get 10 plus 3, which is 13. If you then took that number and subbed it into the inverse, you'd get 13 minus 3, you'd be back to 10. It undoes what the previous one does. That's the big picture, okay? So how about this one? Have I explained enough that this is going to be easy? If f at x is x minus 9, what would the inverse function do? X plus 9. If that's all there was to it, I'd probably just stop the lesson. These are one-step ones. All we got to do after this is, what if there's 2 steps? That's all. That's all we got to manage. And we'll talk about that in just a minute. So we'll just do a couple more just to really get this practice down. If f at x is 6x, then the inverse, okay, now you got to think a little bit. What does 6 times x do? Multiplies by 6. So what does the opposite of multiplying by 6? X over 6. Should have seen how excited I was this morning. They came to measure for my new active board. It's coming soon. Excited. All right. Is this going okay? Everything's good? I know the new symbol's weird. It's weird. It's a weird symbol. I don't know what to tell you. So the inverse of f at x equals x over 20. This function divides by 20. So what would my inverse function be? Multiply by 20. So I'll just write 20x. Again, I'm almost done this lesson. I got some details to do. All I got to do is what happens if there's 2 steps. You're like, Ms. Todd, you rigged these first ones up so they're all one step. That's pretty easy. If there's 2 steps, we just got to work out the 2 steps. That's all. Nothing extra here. Any questions there? Notice I've taken to holding on to my microphone thing instead of just put it away. Stop fiddling, Mr. Todd. All right. Do you need more time there? Yeah. It's nice with the copies, isn't it? Things go a little faster around here. The inverse of f at x equals x squared. What's the inverse of squaring? Root x, yes. Just leave a little space. I'm just going to leave a little space because we got to talk about something with squaring. Squaring is a small problem. And it's our fault. I take the total blame as a math teacher that we messed you up with squaring just a tiny little bit. That is, the first time you see squaring is probably the Pythagorean theorem. So you maybe ended up with something like this. Here's just me thinking in a little thought bubble to explain something I got to do here. And the first time you saw it, it was c squared equals 25, something like that. And so when we taught you that in grades 7, 8, or 9, depending on when you first saw it, we said, okay, to undo squaring, what you do is square root. And you get the answer. You're happy. You should be happy. You're like, yep, seen that. Okay? However, it worked for Pythagorean theorem because we were looking for the length of a side. But there is another number that you can square and get 25. What's the other number that squares to give 25? -5. The x squared is not 1 to 1. There are 2 answers for things with squaring. So from here on in, you didn't have to in grade 9. The grade 9s don't got to do it because they're looking for the side of a triangle, so they don't need the negative answers. But we'll need the negative answers. So from here on in, and I put it in a separate color here, anytime you do the opposite of squaring, you should do a plus minus. Do you remember seeing this plus minus somewhere in grade 10? The plus minus came up in the quadratic formula because it's up for exactly this reason. There's a plus minus in this situation. That's annoying and totally true. Yeah? It doesn't happen when you're doing the opposite of square rooting. You don't have to worry about that with the opposite square rooting. So when you do f inverse of this one, that's just x squared. You're like, wait, why wouldn't you have to do it the other way? There's a problem. There is a problem. There's a problem looming out there. And it has to do with domain and range. We won't get too far down that line. For now, if you got the plus minus, I'm pretty happy, and we'll continue to explore inverses. Because there's a whole section on inverses in advanced functions in the next course. We've got to keep talking about inverses. This is like intro to inverses, okay? So far, what have I said? Opposite function, use f to the negative 1. And if you're doing squaring, you need plus or minus square root. More on that in just a second. Do you need more time there? Okay, here's the only thing. Whole lesson right here. So if you've drifted off to sleep, or your brain was never quite in it, this is the one you want. This is the one you want to pay attention to. This is what you got to worry about in grade 11. This is the kind of one I'll put on the test. It says, find the inverse of the function 2x plus 3. See, it's got 2 steps to it. The method I'm going to show you will handle 2-step, 3-step, 5-step. Once I show you how to do 2-step, you'll be able to do any number of steps. That's not going to be a problem. So don't be scared, oh, what about a 3-step one? You don't have to worry about that. What I show you here will handle other number of steps. There are 2 ways to handle it. It's what I'll call the function machine method, which is essentially just thinking this thing through. That is not the way you're going to want to do it. The algebraic method is very powerful. It handles any situation. But I want to show you this one first so you know what's going on. Let's talk about what f at x does. So if I was going to make my machine diagram again, do you remember this from the first lesson of the chapter? Here's a machine called f at x. What does f at x do? If you were to sub a number into f at x, what's the first thing you do to it if you subbed it in there? Multiplication. So the first thing it does, let's put those in order. The first thing it does is multiply by 2. Okay, all brain cells on for just a moment here. There's one little thing. This is the quirk I said on this that you got to watch out for. Then after you multiply by 2, if I sub something in there, let's say I put a 5 in there, I'm going to multiply by 2, then I'm going to add 3. So that's what the function does to numbers. It multiplies them by 2, then adds 3. So the inverse function has to undo that. Did you hear me slow down my voice there a little bit? I didn't say has to do the opposite, because the opposite's not quite clear here. It has to undo what's been done. I'm going to say the next part quick because I usually have better luck saying this part quick and accessing your brain. If I want to undo multiply by 2, then add 3, and I want to do that in reverse, what should I do first? Subtract 3. Let me say it fast again. Fast, I think, works. If I want to undo multiply by 2, then add 3, and I want to undo what's happened, I'm going to have to subtract 3 to undo that first. The last thing I did is the first one I want to undo. I've got to peel back what just happened. Imagine unwrapping a Christmas present. Have you ever got this funny Christmas present? We used to do it about every couple of years to someone in our family. It'd be something small. You know, maybe it's a piece of jewelry. And so you wrap it in a little box. Yeah? And then you take that box and you put it in another box and wrap that box. And then you take that box and wrap it in there. So the person's unwrapping for 15 minutes to try and get to the present. But the present, when you come in, you bring this big box and they're like, oh, wow. And they open that up and it's just a box inside. They pull that out and they unwrap it. It's not long before they know what's happening and they end up getting a nice pair of earrings at the end. Okay? That's a little like what's going to happen here. Whatever the person wrapped here, whatever the last layer of wrapping paper they put on, that's the first one you got to peel off. The last thing they did here was add 3, so you got to first subtract 3. Before that, they multiplied by 2, so you got to divide by 2. I hope you're watching all that steps and going, oh, I understand what you're saying. Beautiful Christmas example. Please tell me I don't have to go through all this every time to figure out what I got to do. No, I've got a way to algebraically shorten that down. But after all that, is there anybody who can make up a function that first subtracts 3, then divides by 2.
X minus 3 divided by 2.
X minus 3 over 2. That function will subtract 3, and then it will divide by 2. Remember, this is where I want you to be at this point, where you're like, okay, I get that. Please tell me I don't have to do that every time I have to do 2 steps. No. Here's an algebraic, ultra-powerful recipe, procedure, algorithm to do exactly that question without all the crazy thinking. It looks like this. Step 1. Replace f at x with y. So instead of writing it with an f at x, change it to y equals 2x plus 3. There's absolutely no reason to do that except to make the algebra easier. That's the only reason. F at x means y, so if we're going to do some algebra with it, let's just call it y and make our life a little easier. So that step is sort of a non-step. I haven't done anything yet. 2 is the whole deal. 2, I'll do it in capital letters. To get the inverse, exchange x and y. Oh, that's the whole deal right there. It turns everything around. It says, oh no, we don't want to do y and x that way. We want to do the inverse, so we're going to flip those two things. We're going to make the x's the y's the x's. We're going to reverse this whole thing. So I get x equals 2y plus 3. The rest is pretty straightforward. Solve for your new y. The new inverse y. I've got a new y in there. I exchanged x and y. So you're just allowed to exchange x and y? Yes, if I'm finding inverses, I'm allowed to totally exchange them. So I got to move this around, right? I got a little bit of algebra to do. There's lots of ways to do this algebra. I'll do it a sort of difficult way. You can decide if you're better at it than me and can do an easy way. The sort of difficult way is, okay, I bring the 2y over here and make it negative. Move the x over here and it becomes negative. And then divide everything by -2. Fighting with my actor board here. Look at that. Can't barely write on it anymore without it hitching on me. Jeez. It's not the same. Hold on, Kyle. It's not the same. It's not the inverse. And it's because of the way I did the algebra. Negatives are tricky. They mess things up here. So if I want to fix this to look like that, I just multiply top and bottom by -1. As soon as I finish that, I'm going to ask if somebody else has a better idea to do the algebra that'll make this a little easier. Anyways, this is y equals x minus 3 over 2. When I multiply top and bottom, you see, I've got it. There it is. I've got the inverse. Well, let's talk about this for a second. See, I did this a certain way, this x equals 2y plus 3. Let me just put a little thought bubble up here and go, could I have done this an easier way? Let me help your algebra here. As soon as I moved that 2y over and it became negative, sort of getting myself in trouble. You know, I'm asking for trouble with the negatives. If I'm solving for y and it's already positive over here, why not just leave it there? It's good, it's nice, it's positive there. So you can save yourself a little bit of headache by instead isolating the y over here instead of over there. That's going to solve your negative troubles for you. Then when I divide by 2, I'm done. That's a little more experienced algebra, where you're like, I don't need to bring it to the left. I'll put it the place where it is, where it's positive. If you're right with me, you could just exchange these two sides. You could also do that. Yeah? Okay. Step 4, write y as f inverse of x. So f inverse is x minus 3 over 2. Now, if you're looking at that and you think, well, actually, you did a great job of selling your new method, but I think I like the old method. Here's the problem. For a two-step one, this method actually is probably pretty good. For a two-step one. But if it's more than 2 steps, this is a nightmare. Whereas this works for any situation. So that's why it's called the powerful method. It's not called the easy method. It's called powerful. I'm going to do 3 more. So if you're looking at this going, maybe, sorta, I'll do 3 more.
Mr. Clannon, could you please page the main office? Mr. Clannon, please page the main office. Thank you.
All right. But knowing that I'm going to do 3 more, we talk in this in calculus all the time. The first example I do, don't panic. Just wait. Let me do a couple before you start giving up on the whole thing. It's usually about the second or third example you start to go, oh, okay, I'm starting to get it. But knowing that, do you have any questions about the procedure? It's not easy, but the nice thing about it is it's the same every time. The steps are the same every time to find an inverse. Replace f at x with y, exchange x and y, solve for y. Those 3 steps stay the same all the way through. Okay. More time here before I do 3 new ones? Okay. 3, I don't know if these are quite as hard as the homework gets, but this is pretty much as difficult as we're going to deal with. I put some negatives in there just to make us fight with negatives a little bit. Does anyone, without peeking, did you hear knocking? Or am I having a stroke?
Is this a bad time to?
No, it's a great time. Come right in. How long is the presentation?
Just like 2 minutes.
Oh, you might end up on my video. You'll be online. You'll be famous, but go ahead. Go ahead.
We're doing a fundraiser for our leadership class by collecting pop tabs and donating them to retired veterans. Every Tuesday and Thursday until November 9th, we'll come around and collect them.
And the winner of this gets a big prize.
Oh. May I ask a question?
Yeah.
In the past, when they did these, the pop can fundraisers, sometimes they'd give us a
Yeah, we're
cup with a...
Yeah, we're going to come get a cup.
Great stuff. Would you put it on? Perfect stuff. Thank you. Great stuff.
Well,
Thank you.
sorry to interrupt.
Not at all. Not at all. It was the perfect time for a mental break. Now, without peeking back, let's see how much of the procedure you can do. This is a great memory tool. Force back now. What was step 1 in this? It's f at x equals negative 3x minus 9. I'm trying to do the inverse. Do you remember what we step 1? Put y in there for f at x. That does nothing except make the algebra more manageable. That's all. It's just making our life easier. So step 1. Replace f at x with y. You do not need to write that every time you do it. I'm doing it because I'm teaching. You'll just go like this. Okay, inverse, y equals negative 3x minus 9. Now, the important mathematical algebraic step. This is the part that actually finds the inverse. Do you remember it yet? Do you remember it? Exchange x and y. So maybe this procedure isn't quite as hard to remember as you might have thought. Exchange x and y. And again, you don't even need to write that. You did that. Once you get good at these, I'm only doing it because I'm teaching. 3. Maybe somebody's got it already. They already know all 3 steps. What's the last? Well, it's not the last step, but what's pretty much the last step? Solve for the new inverse y. The way she said that is perfect. It seems like there's some trickery going on here. I've made new y's and x's. And the answer is, yes, I totally have. I've made new y's and x's. So I'm going to solve for the new inverse y. And you don't have to write that either when you're doing these. Shh. But I do have a question. A little algebraic wisdom here. It's negative 3y right now. Which side do you want to put it on? Just to make my life a little bit easier. That one, bring it over. That'll keep your positive, negative life a little more in order. So is this too much algebra for one step? You look at that and see. Or if that's like, yeah, I got it. I can move two variables at once. Grade 10s get very stressed when you do stuff like that. Like, well, what'd you do there? What'd you do there? The negative 3y came over and became positive 3y. Actually, subtract 3y came over and became add 3y. And then this x came over. And then my last step is? No, it's not the last step. It's mostly the last step.
You gotta multiply that negative.
Now state the inverse. Yeah? State the inverse. After you solve for y, you really do have the inverse. But we should state the inverse and go, oh, that's the inverse function right there. Okay. I'm going to do this one without writing the steps. You've got the steps right there in your note one more time that you can refer back to. But this is how most people do it. They see f of x equals x plus 7 over 2. They write y equals x plus 7 over 2. Then they write something like this. They go, okay, exchange x and y. Just to note to themselves what they're doing here. So I get x equals y plus 7 over 2. Really, the inverse is done at that point. I've done the inverse. We're only solving for y so we can see what the thing is. So opposite of dividing by 2. So I get 2x equals y plus 7. What do you want to do here? What do you want to do here? You want to bring the y over? You want to keep it where it is?
Bring it over.
You can. You can totally bring it over, and then it'll go negative, and as long as you know how to deal with that, you're fine. But some people are like, no, I'm going to start solving for these y's on the right side when they're already positive there, just to keep my life out of negative trouble. Yeah? So then state the inverse. Therefore, the inverse is 2x minus 7. Let's just do a little check, though, with our brain, though. Does it seem right that the inverse of adding 7 dividing by 2 would be multiply by 2, subtract 7? Yes. So you can still use your brain to look back and see if it seems right after those steps.
Wait, what?
You're like, can I just do them in my head then? No, I'm giving you nice easy ones. If it's 3 or 4 or 5 steps, the new method will handle it no problem. But you don't want to be messing around with your brain if it's a lot of different steps. Yeah. What's that?
Yes, Rob. Because don't you invert the 9?
It stayed on the same side of the equation. It never moved. It never moved around.
Yeah, but you still have to invert it, right?
Not if it doesn't move past the equal sign.
Oh. That's like when you're solving it, but like when you look at it, like you have to invert everything and then.
Only if it moves past the equal sign. It did not move past the equal sign. Let's keep score. Negative 3y moved past the equal sign, so it had to change operations. X moved past the equal sign, so it had to exchange operations. But negative 9 stayed there the whole time. It was unaffected by everything that went on there. Okay, this one's a little bit of trouble. Let's do the steps. Replace f at x with y. Again, that isn't doing anything. That's not getting an inverse. That's just getting the algebra easier, so we're not carrying around f at x. We can work with y. Exchange x and y. I often do see people write that step anyways. I say you don't have to write the steps, and that's true, but lots of people do write exchange x and y because that's the important step. That's what we're doing here. And I get x equals 3y squared minus 2. I offer another algebraic wisdom. If this whole thing, keeping it on the right, that bothers people. Some people are like, Mr. Todd, I don't like solving for y's on the right. You can do this move. This is allowed. Just move everything. That keeps things positive. That's another way to handle it. If you don't like that, well, don't do it. If it upsets you, but all I'm saying is if x equals 3y squared minus 2, then 3y squared minus 2 equals x. And I've kept the positive on the left. I kept the y on the left. I can do that as well. You can keep the other ways. You don't have to do that. I'm just offering some algebraic wisdom here on this whole thing. What am I doing here, by the way? I'm solving for y. Okay, 3y squared minus 2. Oh, no, not minus 2. I'm bringing that minus 2 past the equal sign. So when it goes past the equal sign, it becomes x equals x plus 2. I almost lost my squared there. Move that up there. Now divide by 3. See, this is not one I'd want to try and do in my head. X plus 2 over 3.
Wait, but what happened to the square? Isn't the opposite of square root?
Yep.
Oh, we haven't got there yet.
Yeah.
Alright.
We're peeling it back, right? Like the present. I'm like, oh, that's another layer all the way down. I keep peeling back layers here. And then so I get, ooh, now I need somebody who's been paying attention. What's the inverse of squaring?
Square root.
Yes. Plus minus square root, yeah? It's not going to be built into you, and it's our fault. You can be mad at us because we let you away in grade 9 with just doing squared square root. Because we knew we needed the positive answer, but you're not going to explain that in grade 9 while you're doing Pythagorean theorem, the whole plus minus thing. But from now on, anytime you undo square, you got to do plus or minus square, because there's 2 different numbers that you could square to give that number.
Why is the whole thing squared though?
The whole thing square root. I'm moving squared over to this side, so when it gets over here, it square roots anything that's over there. Now, that's pretty good. You write that on an inverse question, I'll mark it right every time. But just incorporate with what we've been doing so far. Let me just write it a slightly different way. Left 2, horizontal, stretch by factor 3. You know, that we can see those things if we just take that coefficient and put it out front, okay? So this is good. Totally fine right there, but this is what we're going to need to be able to see all the transformations that we've been working on. What do we got for time here? Senior period 3. No, we're senior period 2, 12:15. Oh, I'm still okay, because I think I only have one more to go, do I? I think it's on 2 pages on mine, but I think I got one more to go. Am I correct? Yeah. Oh, no, I got 2 more to go. One really easy one. Really easy. Best question ever coming up, and then one longer one. Okay, I know. More time here? I'm not going to take the time to over-explain this. If they just give you points, you only need one step in this whole procedure. Exchange x and y. So if this is the function f at x, here's f inverse of x. Jeez. Exchange x and y. That's all I'm doing there. Somebody says, wait a minute, why did you do that? Well, if the regular function takes -2 and turns it into -8, my inverse function has to take -8 and turn it back into -2. It has to undo what was done. It has to be a reverse mapping. So those questions you should like. You're like, okay, that's nice. But it's a powerful weapon. It's going to come up. It's an interesting, powerful weapon, the ability just to find inverses by just exchanging the x and y values. It's what I was doing before, except I had to do it algebraically, so that made it a little more difficult. Is this inverse also a function? -8, -2, -2, 0, 4, 3, 7, 4. Yeah, it's okay. But that, me asking that question should scare you a little bit, because you're like, oh, maybe the inverse isn't a function. To step ahead a course or two, maybe it fails the horizontal line test, so when I do the inverse, now it fails the vertical line test. We don't have to know all that yet. We just have to look like we did before and go, is it an inverse? Is it still a function? Maybe it's not still a function anymore.
So we don't change the signs, we just flip them?
Yep, just exchange x and y. It's not equation solving, so we're not exchanging the signs. Questions there? Don't overthink this right now. It's just like flip the x and y's. That's all you got to do for inverse if you've got the points. Last example, straight off the test. We almost always ask a question almost like this on the test. Here, let me put a star in there. There's a test hint for you. There's almost always a test question. Not a quiz, not on the quiz on Monday. Test. I got this section and one more to teach. And then we're done the chapter. So there is a test looming in your future.
Can we just inverse the equation and do it?
Yeah. No, I don't think this is particularly difficult. It just asks you to do a lot of things. It says find the inverse of f at x equals x squared minus 1. I'll do it reasonably quickly. Not to rush the lesson because I got 17 minutes. Not to show off because I got better things to do than show off to you. But to show you that this method doesn't have to take long. Once you're good at doing inverses, it shouldn't take all that long. You write y equals x squared minus 1. Here I'm going to exchange the sides because I want, oops, nope. I'm going to exchange the x and y. Hold on. X equals y squared minus 1. I'm going to exchange the sides. I really like that move. If the y isn't positive, going to be positive when I bring it over, I just exchange everything. And that's not as magical as it looks. That's just me saying if x equals y squared minus 1, then y squared minus 1 equals x. Solve for the y. Plus or minus. I got to build that in. That's an annoying little feature here. Plus or minus root x minus. Oops. And then write it as the inverse. Here's the inverse function. I paused for questions because I wasn't trying to rush it. I was trying to show that the method itself can be fairly quick. There's no reason finding inverses has to take very long. Now, it asked me to graph f at x and the inverse. Is this a simple enough function, after all your experience with transformations, to just graph x squared minus 1?
Wait, yes.
What's the base function?
X to x squared.
X squared. And what's the only transformation that's happened?
Plus 1. Or minus 1, I mean.
Minus 1.
Yeah.
It's down 1. So here it is. If you need more steps, I totally get it. I'm not trying to upset you. I'm just trying to say, I hope that you don't need a whole lot of help from me now to come up with this graph. If you do, well, then you know what you're doing on Saturday. Get back and do those homework sets so that you can graph fairly simple functions quickly. But it said also graph the inverse. Oh, let's take a little time on that one. Root x plus 1. What's the base function? Root x. But what does the plus 1 do?
Shift it up.
Shift it.
Down, I mean.
No.
Up.
No.
Right.
No.
Left.
Left. Left.
Oh, because it's a plus, so it turns to a negative.
Right. Plus 1. So.
And it's in the brackets. Or it's in the thing. So it's all.
And I'm going to make a mistake here. Get ready. Not a mistake. I'm going to leave something out.
Oh, you left something else, sir?
I did leave something out.
You got to do it because it's plus or negative, right?
Yeah. Plus or minus. There's the plus.
Please excuse this interruption tonight. Kayla Cabral to the office, please. Kayla Cabral to the office. Thank
So
you.
loud.
Yeah, the new lady, like she's in it to win it. It's like she worked at a hospital before. Like, Dr. Smith, please report to surgery. Woo!
They just switch it though, right? Now you just switch it.
You just need the minus version of it, right? Plus or minus. Do you see how that red one doesn't look like the inverse of the, like it can't be the inverse. It's not the same thing. But this one is plus or minus, so I get this lower one. I promise it'll pay off if you study this question. This is the big question of inverses, being able to do this. Is the inverse a function?
Yes. No, it is not.
No.
The line test says it is not.
Yes. Let's step ahead 2 courses. 2 full courses. The original blue function fails the horizontal line test. So its inverse is going to fail the vertical line test. This function is called, it's not called, hey, you don't need to know this, but it's not one-to-one, it's called. So no, the inverse isn't a function. Like, yo, Miss Todd, course is called functions. Don't do stuff that's not functions. Well, we're just going to dip our toe in it just a little bit. We're just going to reach out and go, that one's not a function. Right? D, find the domain and range. This is interesting.
That's got to be easy though. It's really easy.
I hope so. But it's interesting what happens here. Watch the domain and range of these. Domain D. Domain. I'm going to do the domain of the original function in blue. X element of reals. Range y element of reals such that y is greater than or equal to negative 1. Hopefully that's becoming easier.
And that's it though, because there's no deep because you can go on forever, right?
Yeah. Now, the red function, domain x element of reals, I'm just looking at the graph here, such that x is greater than or equal to negative 1. But the range this time,
Wait, that doesn't make sense.
you got to stop saying that phrase, man. That doesn't make sense. That doesn't really work in math class. We're the one class where everything does make sense.
Oh, okay, well, it makes sense. I just don't understand it.
Good. I like your new phrasing. I really wasn't trying to be funny. I was trying to work on the language. Before, hang on. Let's assume I'm right for a second, because there's a very good chance that I'm probably right about this. Yeah? And let's look at the domain and ranges for a second. And can anyone see what the heck just happened with the domains and ranges?
Yeah.
Look at the domain of the blue one and the range of the second one. They just swapped the x and y. You're like, oh, swap x and y. Look at the range of the first one and the domain of the second one. The domain and range have also switched x and y. So that's true to this here as well. Now, which part did you want to talk about, Kyle? That
No, I do understand. I just saw because when you wrote the blue, I was like, I thought you were trying to do it for the inverse, but then I
yeah, I tried to color code it there, but you see what maybe you're going to have to label it. You're going to have to say, okay, the blue one, this is f at x,
And that's an egg.
and this one's the f inverse. I didn't because I was color coding it, but I probably should have wrote it. Any questions there?